5-4 is logarithmic functions. Okay, so evaluate the common log, evaluate logs with other bases, solve exponential log problems, solve general exponential log equations, and convert between exponential and log is our current goal. If you're currently in Algebra 2 right now, these are things that we've been working on for 2.5 weeks. Yeah, and we're about to do in 1.5 days. So here are the log rules that we run by. If you have two values that are being multiplied within a log, they can be separated into addition, and vice versa. If you have two terms that are being added together and they have the same base log, then they can be condensed to multiplication. Rule 2, if you have two logs that are being subtracted with the same base, then they can become a division. You can divide the two values. And your power can become a coefficient. The key things to remember here is that your base has to be greater than 1, and your m and n must be positive. Yep. Nope. Now, Kelvin, your year we did not do this because we were in quarantine. Well, y'all did it on Edmentum. If you did your Edmentum. Yeah. I remember that. But I didn't. Yeah. They did. No, they didn't. They told me. All right, next we're going to talk about going between logs and exponential. Okay, so we have a log function of base a, n equals x. It can become an exponential. Okay, so I'm kind of not a big fan of how it's written in our textbook. I typically use b, x, and y. So for me, when I write it as log base b, x equals y, that just helps me remember b, x, y. It means it's alphabetical, right? My base, x, and y. And then it would become x equals. And then it's your b to the y. So I like to say, tell your x by. Bx equals y, tell your x by. Get it? Or you can remember what the textbook said. Leave mine alone, I know. But it helps me to remember it alphabetical and then tell your x by. But basically, this is just saying that they can be converted, and you could do this with either one. So when you have common log, that means that your base is invisible, but it's a value of 10. When you have natural log, what that means is that you had log base e, but instead of writing log base e, you just write it as ln. And that's why the base of the exponential is e. So this is log, common, and natural. And no, I do not know why natural log is not in L instead of ln. Don't know. Have yet to decide to take the time to look it up. That's okay. All right, so let's put this to work. So here we have log 10,000. So this is common log because the base is not present, so that means it's 10. And you want to know, what does this equal? Oh, is that why? Yeah, Latin is logarithms, gotcha. Okay. So we have our b, our x, and our y. So remember I told you to tell your x by, which means that we're going to have 10,000 equals 10 to what power? So what is 10 to what power equals 10,000? Mm-mm. 10 to the fourth. Remember when you're trying to figure out powers of 10? It's based on the number of zeros. So y would equal 4. My pen did some weird things. There we go. All right, let's try it again. So you have your 10, your base, your x, your y. I'm sorry, it equals y. I don't know why I did that. All right, because there's a 0 here, this 0 means that it actually belongs in the front. So this actually moves to the front, and that was our rule number 3, our power rule. So rule number 3, I can rewrite this as 0 log 10, 7. Which is just what? What's 0 times anything? 0. Because it's common log, and when there isn't a base value, a base present, that means that the base is 10. Okay, this one we have 1/10. So again, your base is 10. So here's your base, your x, and what does this equal? And again, we're going to say by to our x. So that leaves us with 1/10 equals 10 to the what power? Kind of 1. It has to be a -1. Because my 10 is where? In the bottom. It's in the denominator. It's in the denominator. Yeah. You just said something for the fun of it. Oh, well, don't take that from us. I thought you knew what you were doing. Okay, cool. We'll pretend like you did. All right, we're going to simplify the cube root of 100 first. So the cube root of 100 can be simplified by breaking down 100. 100 means you have 10 squared. Agree? Yes. We agree with that? Yes. Okay. Cube root means that you're dividing that by 3. So instead of writing the cube root of 100, we're saying 10 to the 2/3. Okay, that's equivalent. So this means that log, I put the word log 10 to the 2/3. Now this is a special property in itself. It's the inverse property. If you have the log times the base of what the log is, they cancel each other out. So since I have common log and I have base 10, all I'm left with is 2/3. So the answer would just be 2/3. How do you know you got base 10? Remember, it's common log. If there's nothing there, then the base is automatically. Nope. So look, if you have here, this is 10 equals y. So you're looking for 0 equals 10 to the what power? And can that happen? Let's talk about it as a graph. So I want y'all to think about that. If you can't think about it, try graphing it. So if I graph 10 to the x, can it ever equal 0? So we're going to go to the graph. I'm going to put 10 to the x. And I'm going to go look at my graph. And what happens here? It's an asymptote. So is it possible for me to ever equal 0? No. So that means that it's no solution. Undefined. And why is it undefined? Because of asymptotes. Undefined.
I have a question.